Ok, benvenuti a questo seminario del centro Nexa, il titolo è Longevity by Design, AI, Data and Healthy Aging. L'ospite è Johannes Walter, EU University of Applied Science, è giusta la pronuncia?
Giusto,
ok.
giusto.
Benvenuto Johannes. È ricercatore che all'intersezione di varie discipline, dall'informatica all'innovazione, economia, la regolamentazione delle AI, ci parlerà di più aspetti nell'argomento di oggi. Il seminario sarà in inglese, Johannes parla bene l'italiano, ma preferisce tenerlo in inglese, la lingua del lavoro. Come ricordo soprattutto chi è connesso da casa o da remoto in generale che l'incontro è registrato e potrete intervenire dopo il seminario. Non sento, ok. Ora mi sentite? Che il portale ogni tanto fa.
Questo. E non è quello, però.
Adesso mi sentite? Se può qualcuno darci feedback? Ah, ok,
Sì,
bene. Per semplicità non ripeterò tutta l'introduzione. Stavo ricordando che il seminario appunto è registrato e nella seconda parte, se vorrete intervenire per chi è connesso, basta intervenire nella chat oppure prenotarsi per un intervento e si può intervenire anche a voce. Facciamo come nostra consuetudine a Nexa un brevissimo giro di tavolo, così Johannes puoi sapere chi hai davanti. Allora inizio io. Antonio Vetrò, sono docente di ingegneria informatica qui al Politecnico di Torino e faculty fellow del centro Nexa.
Maurizio, io insegno software engineering qui al Politecnico e per interessi miei personali mi occupo di well-being, health da un po'.
Maria Bergantino, responsabile della comunicazione qui al centro Nexa.
Io sono Viola Negro, sono fellow del centro Nexa e quindi mi occupo di civiltà cinese e tecnologie digitali.
Io sono Guardario De Marti, ingegnere informatico e co-direttore del centro Nexa.
Bene, quindi di nuovo benvenuto, grazie per il tuo seminario. Prego.
Grazie, and thank you for this wonderful introduction. Today I will talk about longevity by design, AI, data, and healthy aging. There are three terms that are often confused by talking about longevity, health span, and healthy aging. Usually longevity refers to lifespan. That means the survival and mortality, life expectancy, and the population level. So how long do we live? The World Health Organization concept of healthy aging is shifting the goal from living longer to functional ability, to participation and independency. So the question is, how well do we function as we age? The health span, and this is important, very important, also used as research shorthand for the years lived in good health, and is often explained as disease and disability-free years. So we ask in research how many years are lived in a good health. And in this presentation, I use longevity by design in the meaning that continuous data and AI protect function earlier while keeping responsibility and the final clinical decision with humans. So, healthy aging is not living longer. I go on with the definition of the World Health Organization. That means healthy aging is the process of development and maintaining the functional ability that enables well-being in older age. So what does it mean? At first, our intrinsic capacity, like physical and mental capacities, our environment, the communities who care, supporting housing services, and then our functional ability. So what people can be and do for their health. So why now? Why it's important now? Because the health system pressure in all over the world, not only Italy or in Germany, pressure is rising at the same time as technology readiness. So on the systemic side, chronic multimorbidity is rising. And many disease processes have long trajectories. So we need resource constraints and prioritization that are central. In episodic care, now we have episodic care, struggles to learn due to a lack of feedback loops. So on the technology side, we have now broader measurement. So we can have standard labs, data from wearables, for example, imaging, and more information about your genetics. AI, at this point, can help structure heterogeneous signals and translate that signals into decisions. The system's biology today focuses on interaction, feedback loops, and emergent behaviors. So on the one side, you can't measure health using just one metric. This is very important. Health is an emergent behavior of coupled processes like metabolism, hormones, or inflammation. But chronic disease, for example, is a dynamic disease. So often we see compensation for a long time, then gradual drift, and finally symptoms become visible. Okay, so prevention of these diseases, for example, requires monitoring systems, not only isolated markers, biomarkers. So operational, that means measuring functions like mobility, fitness, or strength, measuring stability, metabolic control, inflammation or sleep, or also the recovery capacity. And in these points, AI can integrate multiple weak signals, okay, like mobility, only mobility biomarker, fitness, into an interpretable picture. So the healthcare model is being forced. We need to redesign it. Today, we have an episodic model. Care starts when symptoms appear. And we use fragmented data across providers. The consequence is that learning is hard because outcomes and upstream signals are not routinely connected. We need a new design challenge. A continuous model flips this logic. Care starts with risk signals, not only with symptoms. Decision support is embedded in workflows in clinics, and prevention becomes continuous and personalized. So, artificial intelligence supports healthy aging, but only, and this is important, when it is designed as part of socio-technical systems. What does it mean? I brought 3 examples where AI can help also today and maybe better also in the future. There are 3 high-value roles of AI in healthy aging. For example, the first one is early risk detection. AI can identify frailty risk or detect silent disease earlier than traditional episodic care with multiple sources over time. So we have here decision support, but the human in the loop. Then we got better prevention. AI can help personalize intervention, identify who could benefit and support adherence through coaching. And the clinical decision support, AI can support triage and prioritization, act as a second reader for imaging, and reduce medication safety. Why is this important? Healthy aging needs multiple source data. This could be data from wearables that contribute data about your activity, your sleep, heart rate. We have labs that contribute trends and reference changes interpretation. And imaging in radiology, for example, that reveals early patterns. And your social context that shapes exposure, care, access, and feasibility of intervention. So every additional source increases the need for consent management, data quality controls, provenance, and accountability. I structured you this data multiple source streams in the data pyramid as a pragmatic approach that connects at the end scientific ambition with the real world scalability. At the bottom, we have scalable broad signals like data from wearables, smartphone proxies, or also questionnaires. They are imperfect, okay, but they can reach many people continuously at a low cost level. In the middle, we have core measurements like standard labs, polygenetic risk scores, for example, continuous glucose monitoring, and in some settings, also microbiome and genetic profiles. At the top, we have deep phenotyping like proteomics, metabolomics. These are very powerful, but for discovering subgroups and also very expensive. So the design principle is what I think: use deep data to learn which mechanism matter and which subgroups exist, and then translate this into insights and scalable signals. I will talk now about 3 examples, where we can have data and work with it. Multi-omics, for example, is very attractive because it measures multiple orthogonal biological layers. The value proposition of multi-omics are higher sensitivity to path level dysregulation and to stratify responders versus non-responder. Why this matter? Because in prevention and treatment, averages often hide meaningful heterogeneity. Multi-omics only helps if the models are rigorous. If multi-omics signals are used to guide interventions, we need replication and intervention studies to support causality. The next example are genetics and polygenetic risk scores. Polygenetic risk scores can help prioritize monitoring and prevention, identify who is likely to respond to which interventions. But the key limitations are only a few. Transferability across population can be limited. Explained variance is trait dependent, but not a diagnosis, and always interpret with the phenotype of the person. So the most practicable way, in my opinion, are wearables that can turn annual snapshots into daily signals. Okay, so for example, a practical signal to action ladder could be: number 1, a drop in steps for 7 days, trigger and check-in message or a call of your medicine or somebody of your family. Or for example, repeated falls or near falls at home of elderly people point to some safety intervention or physiotherapy. So remote monitoring in a real-world setting, for example, our research project Alfredo, as a practical example of what is feasible. The goal of this research project was in continuous preventive and monitoring in a real-world aging care. We use smart watching and home devices like sleep and smartwatches and heart rate, or we measured steps or also the weight of our participants. And we combined the monitoring with online one-to-one coaching and online group coaching sessions to increase participation, but also the medical variation. So we kept the human in the loop. The implementation involved partners like health insurers or also the Alzheimer's Society of Baden-Württemberg. The value comes from the closed loop. What was our conclusion? So continuous data produces insights. Coaching what we offered, and the medical consultation of the participants, medical consultations workflow turn into insight and actions. So for example, we have prevented a stroke in a participant while we were collecting data, okay, and identified sleep apnea for several participants. Okay, so the outcomes were earlier risk detection and target follow-up instead of blanket screening. So decision support works when it saves attention, yeah? When it reduces cognitive load and administrative work. Why is this important in reality? Decision support must be ended in the moment of work. This means inside the electronic health record, not in separate systems. It must provide calibrated confidence, okay, for the decision. And explainability should match the task also. In the reality check, we find decision support fails when it demands attention by adding, for example, new dashboards or unmanageable alerts. So the most common AI deployments are often narrow. Imaging triage in radiology, measurement tools, and specific screening tasks. So what is feasible today? It depends on evidence and workflow fit. So I pick just one example, prevention. Now, today, we have a rule-based and simple personalization. The next steps are maybe an adaptive program that is evaluated in real settings. And the future vision could be the closed loop prevention at scale. That means continuous signals feeding into interventions. Let's face interoperability. Without interoperability, every integration becomes a one-off project. That means high costs and poor scalability. So, and pragmatic interoperability stack has several layers. At first, we have for example, the clinical terminology standards such as NOMAD, yeah, that define shared meaning between departments or clinicians. We have a common data model such as OMO that supports research and also analytics across institutions. Then, for example, HL7 FHIR supports the exchange through APIs for clinical data. And we have a strong integration into workflows that connects data to action. Okay, so if you want to start just with one thing, focus on patient identity and consent metadata. The core clinical concepts concentrate on problems and medication, but the clear outcomes are defined for evaluation. So interoperability means also scalability. Let's face trust and health data protection. That are infrastructure requirements and not optional add-ons. This is something, yeah, we are not organizing well in the real world, but under the GDPR, health, genetic, and also biometric data are special category data under Article 9. That means every deployment needs a lawful basis under Article 9 of this law. Purpose limitations, data minimization, strong security, and access control. So patients need also transparency about what data is used, why, and with which safeguards. On the AI regulation side, the AI Act introduces the risk-based obligation, especially for high-risk and regulated systems like a healthcare system. It requires documentation, transparency, and human oversight, and also governance structures. So the implementation is a socio-technical problem. AI projects fail in reality because the surrounding system is not designed well. So on the data side, to summarize, we see missingness bias and label leakage or poor provenance. And this must be fixed through maybe careful cohort definition, data contracts, and audit trails. On the model side, we have generalization gaps and miscalibrated uncertainty. This must be fixed through external validation, monitoring, and conservative deployment strategies. On the workflow side, in reality, alert fatigue, no capacity to act, and misaligned incentives can reduce the value of AI, using AI in clinician context. So this must be fixed through embedded AI in pathways and that already exist and reduce work of a clinician. On the governance side, unclear accountability, privacy, or also legal gaps and procurement friction can stop a project. This is very important. It happens all the time in the reality. So this has to be fixed through clear roles, incident handling, and continuous oversight. Now I want to talk about regulated environments. Regulated environments need controlled experimentation. So the EU established or tried to establish every member state regulatory sandboxes in artificial intelligence. So regulatory sandboxes could enable for regulators a learning by testing environment, improve communication with real market participants, and for firms, for example, the reducing time to market, reduce uncertainty about technologies and business models, and provide feedback on requirements and risks. For consumers, sandboxes can accelerate the access to new and potentially safer products and services. So what you can take away from today? I gave you a quick overview of a complex healthcare system, obstacles. You can start with outcomes. Define the health span outcomes you care about and the decision you intend to change. Then design the data supply chain. Be sure about purpose, ownership of the data, interoperability, and retention. Then make evaluation non-negotiable. What does it mean? Use standards and measure utility, safety, and equity. Embedded in workflow, the design goal is to remove work from clinicians. Don't add dashboards. Adoption follows convenience. And govern with clarity. Define roles, accountability, monitoring, and the governance is how you maintain trust over time. Thank you very, very much for your attention, and I will answer your question if you have one. Thank you very much.
Thank you, Johannes. Exit from the screen. So now it's time for questions, discussions, comments. Anche da remoto potete fare le vostre domande anche in italiano, qui non c'è problema. I have started with one question. So first of all, thanks for this very clear overview about data interoperability. You never mentioned data spaces.
Yes.
And which are the place, at least for the European Union, where this type of data can go to in order to create a market. Basically, yes. There is an economic input. So you mentioned APIs and semantics, okay, but if I well understood, in a more decentralized way. Have you ever thought in your projects or encountered solutions with an approach like this, which is a mix of decentralization and centralization?
Yes, thank you for this question. Yeah, we were facing with these problems, with these obstacles in every research project we had, there is no clear solution for that. So we use different law environment to exchange data, monitoring data, or also health data from wearables, for example. And we use an experimental law, for example, in Germany, that allows us to experiment with health data in a research project or a research environment.
Sorry to interrupt you. What do you mean by experimental law?
The experimental law, the regulatory sandbox law?
Yeah.
Okay, this is
I think we don't have such a thing in Italy. Or
you have to this year until August, I think, to implement it. The EU declared 2 years ago that every EU member state has to introduce such a law in their country. And my example is from Germany, the law from Germany. We have to implement it until, I think, August this year. So in this moment, we are experimenting and implementing different types of sandboxes, AI sandbox environments in Germany. I worked in a research project to develop an AI sandbox for healthcare environments. So, but there are a lot of different environments like that in Germany, not only in healthcare.
Okay.
So I think also in Italy, you can use this law and you have to implement it.
I didn't know about that. It is interesting.
Yeah, maybe it could be a new research project, a common research project, yes.
And did you meet, and then I will leave space to
Yeah.
others' comments, a lot of interoperability nightmares, let's say.
Nightmares, there are a lot of nightmares.
So from in my experience from projects in exchanging
Yes.
this type of similar types of data, where heterogeneity is very high, then
It is.
either you take an approach from the top, semantic layer with dictionaries, etc., semantic, and all the data must fit that, or but this is not so dynamic, so
Yes.
it is slow as an approach, or it's by convenience. You integrate data by convenience.
It is
did
by
you
convenience.
experience,
Yeah. Thank you. Very good question, because this is very difficult. We work together in every project with the protection officer of our region and also the federal data protection officer. So for many cases, it is a precedent case. So you don't have something out of the box what you can use. You have to develop it by your own or talk with other researchers who had the same problems in other projects. But it's not standardized until now. So this is why a regulatory sandbox is important. So you can try fearless with partners, with industry, researchers, clinicians, for example, in my example, in these closed, safe spaces, what it is possible, because we need it in an aging society. You will need more prevention strategies, okay? Because it is about financing clinician. It is about how to solve health issues in the society. You can't fix it if you don't collect data today. Prevention is very important in the future, and the technology is now ready for it. So why you don't use it and connect it together? Yes, we have to solve, but you're absolutely right. We have to solve these regulatory nightmares or obstacles, I say. But I think the regulatory sandboxes could be a good step. Yeah, could be a good environment for these nightmares, to address these nightmares.
Other questions? Comments?
I have a question. So I think you touched two points, or at least I think there are 2 points of view to this problem of well-being and healthy aging.
Mm-hmm.
So one is the personal part, what the single individual can do, eating, sleeping, etc., physical activity. And one is the community, the government, the health government, etc. So where would you start first? Or of course, both, but
Individually.
Okay.
Yeah, this is also a very good question. This is also why we wanted to implement it in the research project that I presented before, a low-cost basis to start for individuals and groups. So, for example, for us was important to know what can everybody do or in a group do for their health. It was also in Corona, so we had to do the coachings online. Everybody was at home, so the participants went out for walking. Yeah, they talk about their obstacles. They talk about their weight they lost. They talked with their data streams, with their medications. So, for example, this participant, this woman I mentioned before, had no idea that she has had problems with their heart rate. Okay, this is something the medicine in an annual snapshot, for example, didn't recognize, and he's told her also this, that she was lucky participation in this research project because he found anomalies in her data from her smartwatch. So this is a low level what everybody can do. Talk with your medicine about the data you have, okay? Or for example, in an elderly society, if you fall at home, this could be a nightmare because you can't then maybe participate in community. You can't go outside, you can't walk, you can't do a lot for your health. So this is something maybe you can integrate. You can have a smartwatch if you I don't know, if you fear to fall at home and you're alone and your son or your neighbor can recognize an alert and helps you directly. So you don't are on the floor and nobody helps you. This is something you can already integrate in your environment. Okay, this is something what you can do. Of course, you can eat well. You can do all the stuff without technology, without AI, but AI can help these multiple low-level signals collect, identify anomalies with your medication together. And this is already possible what you can do. It is cheap, and there are only signals. It's not a diagnosis, but there are signals maybe you don't recognize. We recognized 8 times or 9 times sleep apnea in our participants, and they didn't even know that they had sleep apnea. But sleep apnea is correlated with Alzheimer, for example, maybe, or other diseases. But if you don't know it, you can't do something. And this is something Apple Watch, Withings, there are a lot of more producers can help you to live healthier. Okay, this is something at low cost what you can do. Of course, you can ask your medicine for your polygenetic score or your phenotype. Okay, but this is something you can do, but it's very expensive and not for the whole society. Possible because it's very expensive. Okay.
May I add another question? Which safeguards for people, for their data, did you put in place in this sandbox, and which do you envisage in an epoch where data is always collected for a nice purpose, but then is used for other purposes? Let's say, for example, I know that in Germany the health system is based a lot on private health insurances, okay? So what if this data is then used to increase amount of money to pay, because the data says that my health conditions are not those that are declared or also reported by visits, not additional visits. So this is, from the point of view of the health insurance, is an advantage, but from the point of view of the person, is not, okay, clearly. So this is just an example. So which type of safeguards are possible in this context? Because we know that data then is used for multiple purposes.
Yeah, there are also more examples of this. I would answer it is a very good question, and this is very central for every research project or every medical product you produce. I would say we have the law. Yeah, we have the data protection law, and there are principles inside. It is like prioritization and limitation of data use. Then we ask also our participation if they want to give their data by their own away. Okay, we didn't collect it. We asked them to give it away. This is possible because also of the law. You can ask every producer, every platform for your data. Okay, and then you get your data extract. Okay, so you can give it away, and then in the next step, you can prioritize what data could be used for health insurers, for example, and what data it's not used. Okay, and the difficulty is in research project, if a participant, for example, says, "Oh no, after 6 months, I want that my data is not used for this project." So we got another law. It is in Germany. We got another law for experimentation with health data in a protected environment, for example. This is something we can solve by research projects. And for the industry, not in a research project environment, there are more problems. For example, we got in Germany another law. It is for product safety. Okay, it's a product safety regulation. And for example, if you pass the whole process of regulation and implementation and development and medical app, for example, what does it mean with an AI application? Okay, this is an AI application. It is learning, deep learning from data from different sources. What does it mean in 2 years? It is the same AI like 2 years ago, or it's a totally new product. So this is something we are also thinking about, and there could be two solutions. The first is we implement a black box in every software solution, in every AI, so we can say if it's code error, if it happens something, somebody get a stroke or something like that, and the clinician says it's not in my responsibility, it was this app, okay, and the producer says no, it's the clinician because the app was working well, and he has the decision at the end. Okay, this is a major problem, and we try to implement a black box so we can identify in this black box if it was the code or maybe a clinical decision. The second is, and this is also discussed in Germany, maybe we can introduce a funding, and public funding, and every producer or research institute give an amount of money or something inside this fund. And if something happens with apps, used apps in the future, maybe this fund can help the family or the participant. Insurance. It is a public insurance.
There's a long question.
Yeah. It is a long question. No problem.
Yes.
I will read it carefully. We talk about AI lives, we often.
What is a good idea to read it aloud so that we're
Yes.
in the recording?
Okay, so the question is, when we talk about AI saving lives, we often ignore the lives being spent to build it. Yes. The goal of medical AI is to promote well-being and longevity. How do we resolve the socio-psychological paradox of its production? We are effectively building a wellness infrastructure off the back of system trauma, where millions of data workers in global south are subjected to psychological conditions and the secondary PTSD to label the very data sets we use for promoting health and longevity in the global north. So is this truly a breakthrough in health, or it is a geographical displacement of suffering, aka outsourcing systemic collective trauma that violates the fundamental medical of non-maleficence? Sorry for that. Yeah, it is a long question. Actually, there are a lot of questions inside. Yes, this is something I tried to address in my first slide. You're absolutely right. We have to talk about the term longevity. Longevity by design is a buzzword in the reality, and I try to give the whole view of this. So it's not about only well-being, it's about a big problem in an aging society we have to address. So longevity, maybe it's for some individuals with a lot of money who cares a lot on their yacht, stay on their yacht for 200 years. No, this is not something we want. It is something we try to bring together. How can we expand the health span? This is something very important to know. This is why I addressed also longevity by design. This means expanding our health span.
From the point of view of the production, which was also one of the points you touched, do you, in your projects, how data was labeled? Was already coming labeled? So
no,
okay,
it wasn't labeled. No, it was anonymous, and we had to organize the data.
So the work of labeling was not externalized to
No.
this mechanism that were described.
Yes, exactly. No, we had to label it, and yeah, it was a lot of work to do, but yeah, at the end we developed some standards in a research project environment. Okay, we have to clarify this.
Is a recurring issue that in many of our
I know.
Arise.
I know.
We used the models, but the data was.
Yes, I can do another lecture about this. Another talk about this. Yeah.
I don't know if there is. I was seeing that someone was writing. I don't know. Question. No, it was not.
No, I think it was the same question.
She's still writing. Yes, there's. So we will wait for the question. Carlo, se Carlo vuole intervenire con il microfono si può anche, altrimenti nessun problema. Ci sono altre nel frattempo, se ci sono altre anche pezzetti. Ok.
So in Italy, legislative decree number 29 of 2024 introduces measures on active aging, but they are mainly communicative in nature, aiming to promote aware and virtuous behaviors. In your view, could we foresee in the future a European level obligation to pursue active aging, possibly also linked to the use of digital technologies and AI, rather than just policy encouragement? Yeah, this is a good question. I mentioned some visions, some future steps, and this is also something I don't know. I hope so, but it depends also of the implementation, for example, of the regulatory sandbox law. For example, I asked in a presentation of the president of Fraunhofer the same question, and it was about experimental clauses to use data in AI environment. And he told me, he gave me the answer is like, We have in Germany different regions with different data protection officers. It is something for the future, but this is a relevant question. I can't give you now the right answer for it. You're welcome.
He was the former president of the privacy authority in Italy. Law professor.
The questions, comments. Do you have active projects in the same topic at the moment, or these were all past projects?
This was past project. I have in pipeline 2 more projects, but about climate change and also prevention, public health prevention of climate change. This is something I'm also interested in. And it's an EU project. I'm waiting for it in the next days and next weeks. I hope we get a notice about this project. Yeah, thank you.
You know that.
Yeah, it's always the same game. It's the same game.
Yes.
Yeah.
Okay, I see that we can wait maybe if you consider if people are still writing, let's wait. If the answer okay, they just say thank you. So we also say thanks a lot for you saying that. Thank you.
Thank you for the invitation. And yeah, you can find also my contacts and my email address, something. If you want to collaborate with us, please contact me and we get in touch. Thank you very much.
Thank you.